How did non-standard computer architectures impact early invention? Imagine a world where computers didn't follow a single blueprint. Instead, inventors tried all sorts of different ways to build machines that could think and process information. That's what happened in the early days of computer invention. Before the familiar design we know today, many different architectures were tested and used. These non-standard approaches played a big role in shaping how modern computers evolved. In the 1800s, Charles Babbage designed the difference engine and the analytical engine. These were mechanical devices made of gears and levers, not electronic parts. They used punched cards to set up calculations, which was quite different from later electronic computers. Ada Lovelace worked on programming these machines, creating ideas that are still relevant today. Even though these machines weren't electronic, they showed how machines could be programmed and used for complex tasks. Moving into the early 1900s, Herman Hollerith created punched card tabulating machines. These machines used electromechanical parts to process data for the United States Census. They were not computers in the modern sense but showed how data could be stored and processed mechanically. These machines influenced later electronic data processing systems and helped develop ideas about input and storage. In the 1930s and 1940s, several different architectures appeared. Konrad Zuse built the Z3 in 1941, which was an electromechanical computer that used binary numbers and punched film for programming. This was different from other designs that used decimal systems. The Z3 proved that computers could be programmable using binary code, opening the door for future designs. The ENIAC, finished in the mid-1940s, was one of the first electronic general-purpose computers. It was different because it needed to be rewired to change programs, which was slow and cumbersome. This showed the limitations of fixed wiring and led to the idea of stored program computers. Meanwhile, Alan Turing and others worked on designs like the automatic computing engine, which used stored instructions and subroutines. These different ideas about how to organize memory and instructions pushed the field forward. All these experiments with non-standard architectures helped shape the computer designs we use today. They showed different ways to encode, store, and process information. They highlighted the importance of programmability and memory speed. These early efforts also led to innovations in hardware and software that made computers more flexible and powerful. By trying out different approaches, inventors learned what worked and what didn't. Their work led to the development of the von Neumann architecture, which became the standard. This design uses a single memory space for data and instructions and a central processing unit to run programs. Without these early experiments, the modern digital computer might not have been possible. These non-standard architectures were like stepping stones, guiding us from mechanical devices to the fully electronic, programmable computers that power our world today.